today, folks. We are starting our next unit, which let me scroll up to the top here. The last unit of the binder, actually. So we're getting down to the end here. This is when the algebra really kind of ramps up. We saw that our last unit with some new things. Units 1 through 4, a lot of it was review from pre-algebra. We took a pre-algebra concept and just went deeper with it. Starting in Unit 5 with compound inequalities, most of you haven't seen those before. Some of the absolute value equations, you haven't seen those before either. You may have some, you probably do have some experience with scatter plots, but really starting with Unit 6 here, things begin to ramp up pretty significantly. So the POs that we've had in the past, will start to come back. Important, you've got those. But we're starting today with scatter plots. Shh, Edward, we are recording. I'm teaching, so you are quiet. And what a scatter plot does, it's a way to represent and ultimately interpret data. And we're going to start today by creating our own scatter plot. Now, when we were going through the COVID years, I had to change this because I was having you measure each other's height and wingspan, which was not social distancing. So I had to change it, and I got rid of the tape measures that I was using, so I don't even have them anymore. So we're going to have to do some adjustment here on what this graph says. But what we're going to be comparing is the number of wins for an NFL team from this past season, and compare that to the number of points they scored on offense, right? So if you look at the sheet that I handed out, I've got two columns circled. Those are the columns you want to pay attention to. The first column is their number of wins. The second column is their number of points scored, okay? Now, anytime that we go to make a graph, we have to make sure that we're being intelligent. We have to make sure that we're making a graph that's going to be easy to read and accurately represents the data, okay? So instead of heights, I want you all in your binder on this page to replace height with wins. Okay? And then replace wingspan with points scored. Okay? Replace height with wins and replace wingspan with points scored. Now, for the wins, this one's pretty easy to divide up, okay? Because in an NFL season, the least number of games you can win is 0. The most you can win is 17. So we're just going to kind of mark this off by ones. Okay. And if it's difficult for you, if you know that spatial reasoning is not really your thing, if you know that if you start marking this off by ones, you might end up with 17 in the middle because you're really bad at spatial reasoning, or maybe you get to the end and you're only at 10 again because you're not so great at spatial reasoning. That's okay. What's a trick you can use to help you accurately divide this up? You could, okay, if it helps you kind of put 1 in the start and 17 at the end. Of course, our corner value is going to be 0, okay? Yeah. Right, you can mark halfway first, okay? It's a lot easier to look at a segment and say, all right, what's half? Half's going to be right about there, right? And then in that spot, you're going to either put an 8 and you're going to put a 9. Doesn't really matter. We're freehanding this, so either one's close enough. But now, instead of going from all the way 0 to 17, you're only going from 0 to 9 in a smaller space, okay? So let's see. We got 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, fill in those values there. And then you're going to the end to 17. 10, 11, 12, 13, 14, 15, 16, 17. Right? And if yours isn't perfect, mine certainly isn't. Okay, my gap from 8 to 9 is a little bit bigger. My gap from 9, it's okay. But it's good enough for freehand to where we can use this data. Right? And then when we go to points scored, at a quick glance, what's the highest total of points scored? How high do we got to go here on the y-axis? Chase?
496.
496. We can round up to 500 just for ease of values here, right? Do I want to start at 0 and go up to 500 and count by ones?
No.
That'd be ridiculous, right? That'd be ridiculous. What's the lowest point total? Just as a quick scan.
No, it's 280.
I see it 280. Okay. We'll round it down to 250. Anything below 250 that you can see? No. So if we don't have any values from 0 to 250, have you ever seen this in a graph before?
No.
What that little lightning bolt thing means is that there's nothing that we need to cover here. And so we can actually start our 250 right here. Otherwise, you're going to have this big empty space. And then all of our values will be more scrunched up. Because if we don't start 250 until like right here, all of our values are going to be scrunched in the top half. Okay. Whereas with that little lightning bolt, we're saying, there's nothing in the hundreds, nothing to have to worry about here. It's going to allow us to spread our data out more. And the more spread out data is, the easier it is to read. Okay. And obviously, we're still not going to count by ones. What would be a pretty decent divvy up here? 10, that might even get a little bit too crowded. You could if you wanted to, but 25 might be a good way to go. So let's just see. 275, 300, 275, 300, 325, 350, 400, 425, 450, 475, and 500. Did I? Oh.
Mr. Schultz.
Well, counting's not really my strong suit. 4, right? I did. Oh, darn. Okay, we'll try that again. 275, 300, 325, 350, 375, 400, 425, 450, 475, and 500. Not perfect, but good enough. Well, hold on, it's got to. Oh, 425, 450, 475, and 500. So if you've never made a scatter plot before, basically we're using our wins as the x value and the points for, or points scored, as the y value. So our first point there, the Chiefs, 14 wins, 496 points. Their points is going to be 14 on X, 496 on Y. It's going to be right about there. Okay, right about there. Our next one, Eagles, 14 wins, 477 points. They're going to be right about there. Vertically with the Chiefs, because they both have the same number of wins, the same X, but a little bit lower on the Y-axis because they scored a little bit fewer points. Then we have the Bills, 13 and 455. So 13 on X, 455 on Y. It's going to be right about there or so. The Vikings, 13 win. Wait, is that right? That can't be right.
Yeah.
No way. 13 wins, and they didn't win a playoff game? Crazy. 13 wins, 424 points. So that's going to be vertically with the Bills. Right, but below a little bit there. So I'm going to pause the video, go through this, and fill out your scatter plot with the wins as the X value and the points scored as the Y value. Be as accurate as you can, and we will touch base with this shortly. Back in action. Okay, so you've made your scatter plot here. And you can maybe see why it's called a scatter plot, right? Because the points are kind of scattered throughout. You are used to seeing when you plot things on a corner plane, things make a line, right? Every graphing that we've done up until this point have been linear functions. They've been lines. Because what do they all have? Every equation, any inequality that we graph has slope, right? Which is what makes it that linear function. Real quiet, please. Okay? However, this one, Sam, Charlotte, you also. That this scatter plot, you can see there is no slope here. This is not linear. There is not a direct relationship between wins and points scored, or points scored and wins. We were all kind of surprised. At least I was kind of surprised. I think this was the Lions here. You know, they were top 5 in scoring, yet they were barely above 500 there. Okay, why would that be? As a data analyst, what you need to look at is why would that be? What might explain a team scoring top 5 in points but only getting 9 wins out of this comparison?
Bad defense.
Bad defense, right? That's what you might conclude from that. There are a couple outliers here as well. This team here also had 9 wins, but scored like 150 fewer points. Okay? You might conclude that there were a lot of really close games, low scoring games, things like that, right? But when we look at a scatter plot, there's a definition down here called line of best fit. These points don't make a line, but what a line of best fit does, Will, do you know? Oh, anyone know what a line of best fit is, or can you kind of guess what it would be? Yeah. Kind of like the average. Okay, if these did make a line, what would it look like, right? And Edward said an average, when you make a line of best fit, you generally want the same number of points above the line and the same number of points below the line. So I would say our line of best fit is about that. Yeah, maybe I missed a little bit. Maybe it should be a little bit lower. Okay? But the point is, a line of best fit, what it does is it shows, and some of you might have to stand up to see this definition. I don't want to scroll down and lose all my points up here. Shows a general relationship or trend in the data. A line of best fit shows a general relationship or trend in the data. A general relationship or trend in the data. If you look at this, what is a general relationship or a general trend between wins and points scored? Colin.
Generally, the more points you score, the more wins.
Right. Generally, the more points you score, the more wins you have. Generally, the more wins you have, the more points you score. Okay? There's a correlation there between wins and points scored. As the number of wins go up, the number of points scored go up. Is it a perfect relationship? No. But that's the general trend that is there. That's the general conclusion that can be made. Okay? Did anyone get any scatter plots on your math test?
Yes.
Perhaps?
Yeah.
Well, now in the spring,
They use
right?
terms.
what's that?
They use like different terms. Like this is like a right something.
Do they use R, like a correlation coefficient?
No, they just use like these different terms. Like what type of data chart is this?
So, but now in the spring, to get some of those questions, hopefully this will help. This will help with that. Tomorrow we're going to look at interpreting scatter plots. If you kind of jump ahead, there's scatter plots that are there for you. We're going to interpret them. What is the general conclusion? What is the general trend that can be made there? But that is it for today. You can fill out the rest of the page. You should draw the line of best fit, and then what is the general conclusion? Colin. You will need to make one on the test. It's not going to be 32 data points. It'll be like 8 or 10. But yeah, on the test, I'm going to give you something similar to today. You create your own scatter plot. You draw a line of best fit, and you write what general conclusion can be made about it. Okay? So this process is essentially exactly what you'll have to do on the test on a smaller scale. Owen, Will, please stop that. Hold on, we're still recording. There are questions, just sit tight for a little while. Kristen.
Do we need this?
No, you can dispose, please recycle, if you're not, you can keep it. All right, no homework for tomorrow. Khan Academy is due tonight. That's IMath.